All right, so in this video, we are going to do the entire curve sketching algorithm for this equation, this rational function over here. So the first thing you want to do is you just want to factor this function. The top is a simple trinomial, what multiplies to -12 and adds to 1. It's just x plus 4 times x minus 3. And then the bottom is difference of squares, which is x plus 2 times x minus 2. Now that we have this factored, we can state all the important features of this graph. So we're going to start with the x-intercepts. For the x-intercepts, we look at factored form and we look at the solutions to the top. So my solutions are -4 and +3. Then I'll do the y-intercept next. So for the y-intercept, we look at the original equation and we just sub in the x values as 0. So if I make these three zeros, I'm just left with -12 divided by -4, which is +3. We'll do our asymptotes next. We'll start with the vertical asymptotes. For the vertical asymptotes, I'll look at factored form again, and I'll do the solutions of the denominator. So my two solutions are -2 and +2 here. So my vertical asymptotes are x equals to 2 and x equals -2. For my horizontal asymptote, I'll look at the original equation. The degree of the top is the same as the degree of the bottom, and when that's the case, we divide the coefficients. So 1 divided by 1 is just 1. So my horizontal asymptote is y equals 1. Next, I'll just state my domain. And your domain is just x is an element of all real numbers such that x does not equal to your vertical asymptotes or your holes. X does not equal to -2 or +2. There are no holes in this question because none of our factors canceled off. Okay, now that we have all this info, we can start our sketch. We'll do that over here. For the sketch, the first thing we want to do is we want to just draw our vertical asymptotes, I guess. So -2, and then +2. And then we want to label horizontal asymptote y equals to 1. So remember, when you're doing horizontal asymptotes, only do it on the ends. It does not apply to the middle of the graph, only applies to end behaviors. There's my horizontal asymptote, and now I can do my x-intercepts. My x-intercepts are -4 and +3. And my y-intercept is +3 up over here. So now I gotta sketch the graph. It's pretty obvious what's happening on the left side here. Because the point is below this asymptote, it means that it has to come like this and then go like that. There's no other option at all. So you don't have to do any calculations here. That's the only possible shape over here. And this point, remember, was -4. We'll do the right side next, and then we'll go to the middle last. So same idea on the right side. There's only one possibility, and it's going to hug the asymptotes like this because there's literally no other possible way that this graph can go. This x-intercept is +3. Now the middle is a bit tricky because we have this point over here, which is +3, but the graph could be U-shaped, could be N-shaped, or it could also be like a cubic equation, positive or negative cubic equation in the middle there. So in order to figure out which one, we actually have to do some calculations to figure it out. So I'm going to start by taking in a number slightly less than -2. I'm basically going to take -1.9. And I'm going to put it in doesn't matter whether it's the original or the factored equation. I'm going to just put in the original equation and put in my calculator. So negative 1.99 squared, I guess 1.9, you don't have to be that specific, plus 1.9 minus 12 divided by 1.9 square minus 4. And I get that to be 16.64, which is a much bigger number than this. So we know that that point is up over here. It's positive 16. Now I'm going to sub in a number slightly less than positive 2 just to figure out whether this point is on the top or the bottom here. So I'll sub in positive 1.9 in this case. Oh, I made a tiny mistake, by the way. It's 26.38, by the way, but doesn't matter. It's still up there. And now if I change it to positive 1.9, probably will get the same answer. Yeah, it is. Oh no, 16.64. So positive 1.9 is 16.64, negative 1.9 is 26 point something. It doesn't really matter. You just want to figure out whether the points are at the top or at the bottom. And then now we can draw the shape because we know it's going to just hug the asymptotes like this. And that's what our final graph looks like. Our last thing we're going to do is we're going to do positive and negative intervals and increasing and decreasing intervals. Let's start with positive intervals. So positive intervals are where the graph is above the x-axis. So you always want to go from left to right. And that way you cover every single interval. My first point over here is negative infinity. And we can see negative infinity till negative 4 is going to be a positive interval because that's above the x-axis. So that's my first positive interval. Then from negative 4 till negative 2, basically we're only looking at x values. This is a negative interval because it's below the x-axis. So the next one's going to be negative 4 comma negative 2. It's a negative interval. Then we continue over here, which is at negative 2, basically slightly after negative 2. And from negative 2 to positive 2, this is all above the x-axis. So this is my second positive interval, negative 2 till positive 2. Then from positive 2 till 3, this is all below the x-axis, which is the next negative interval. And my last interval here from 3 till infinity is again above the x-axis. So it's another positive interval. So from 3 till infinity. So these are my positive and negative intervals. And last, let's do increasing and decreasing intervals. So if I look at this graph, it starts over here. And then this is a negative slope because it's going downwards from left. You're looking from left to right. So left to right, it's going downwards. So this is an entire decreasing interval. So my first decreasing interval is from negative infinity till negative 2. Then I have an asymptote, which is a break. And then again, I'm starting at the top. And when I go from here to here, again, this is all decreasing because I'm going downwards. I have a negative slope. So my second decreasing interval is from negative 2 till 0. Remember, we're looking at x values here again, not y values. Then from here till here, this is increasing. So the x values are 0 and 2. And then from here all the way till here, it's increasing. So this is from 2 till infinity. And this is my intervals of increase and decrease.